Meet Codename Goose, your on-machine open-source AI agent. Built to automate your tasks, Codename Goose is an intelligent and autonomous agent capable of handling complex tasks thanks to its core features. Connect with apps and tools you already use with extensions. Built on the Model Context Protocol, you can connect to extensions like GitHub, integrate JetBrains IDEs, access Google Drive, or build your own custom integrations for Goose. For a curated list of extensions, visit our docs. With a wide range of compatible large language model providers, you can choose and integrate your preferred model. You can also run Goose as a desktop app or through the command line interface using the same configurations across both. You can think of Goose as an assistant, ready to take your instructions and do the work for you. Able to handle a wide range of tasks across various engineering domains. Here are examples of tasks Goose has helped people with already. Goose has helped dive into a new project in an unfamiliar coding language, conduct code migrations such as Ember to React or Ruby to Kotlin, increase code coverage, and even generate unit tests for a feature, and much more. To get started using Goose right away, check out our quick start and be the first to know about upcoming features by joining our community.
Hello, happy Tuesday, everybody. I'm so glad to chat with y'all. If this is your first time here, you're watching Goosing Around, but this is the edition where we bring in guests who are building or who have built tools that we integrated into Goose. So just to give you all a little bit of background, Codename Goose is an open source AI agent that works locally on your machine, so it's not in the cloud or anything like that. And today we're going to talk with Langfuse. Langfuse does, I'll let the CEO describe it in his own words, but from what I see, it does AI observability. And I think this is really interesting that at Block we're focused on this because I'm seeing a lot of companies, or that we integrated this, because I'm seeing a lot of companies decide like, okay, we're going to build a AI agent, or a lot of people are doing that too because it's the trend. But we're not necessarily thinking about like the infrastructure or any DevOps or observability to make sure that our agents are like long-term and sustainable. And I also don't know that much about observability, so I'm curious to learn more. I'm also going to be chatting with the CEO and an engineer who's worked on Goose. But before I do that, I'm going to bring them up on stage and say hi to them. Hey, y'all. And also say hi to people in the chat right now. I saw Clemens say this like from last night. He's like looking forward to this. So I don't know if he's here right now. Yo to Max, hey to Ace, and Max is apparently cooking up some fun stuff, but he's not going to spoil it. I don't know why you put it like this. What's the word? My brain can't think. The suspense on me. I can't do suspense. All right. So, Alice and Mark. Oh, also hi Tanya. Alice and Mark. I want to ask y'all a little icebreaker before we dive in, just to make sure y'all be like relaxed and everything. So, what's your favorite holiday? Anyone could go first.
Hiking in the Alps. Like mountains are just really nice.
Wait, what did you say? The mountains are nice? Sorry, I didn't miss that.
I said like hiking in the Alps, or generally like hiking in mountains is kind of like favorite holiday. It's just like really relaxing.
Oh, wait. So I forgot. Okay, hold on. Let me see what's another way to say this. You guys say holiday as like vacation, but I'm saying like Christmas, Easter, those holidays. But
Mm.
hiking in the Alps, that sounds nice. I never did that before.
I would maybe do this for Christmas. I don't know.
Okay, that works. What about you, Alice?
I would say Halloween because
Halloween.
I feel like that's when adults get to dress up and act like kids again.
Okay, I love it. If anybody from the audience as well has any, let me know. I will say, like Mark, I think I like Christmas, but I also was thinking, and this is don't judge me, people. It's not for the reason that everybody else would might think. I like July 4th, but not because of Independence Day. It just happens to be my birthday. So that's my favorite. My holiday is my what? Ace said he don't like holidays. I don't know. But I always think it's interesting in other countries when they say holiday, they mean like a vacation where they're going to relax. How, Alice, what about you then? What is like a vacation where like your European holiday?
Maybe somewhat similarly, I like backpacking. So also planning to do a little bit of European backpacking later this spring, summer.
Nice. I like that, guys. Although I don't know, for me it doesn't sound that relaxing. It sounds like a lot a lot of work to backpack or hike. But all right, let's dive in to the actual technical topics here and all that. So for folks who don't know you all, can you give us your name, what you do, and also what you're passionate about?
Sure. I'm Alice. I'm a machine learning engineer on the Goose team, and I work on kind of all things Goose. I've been on the team for maybe 6 months now. And I think these days what I'm really excited about is how do we measure and improve performance of agents. I think LLMs are really like a black box. And while we have public benchmarks like SweBench or how models perform on like math competitions, it's actually really hard to know how they'll perform in the wild on your specific task. And so I think it's really interesting to try out tools like Goose with a lot of different models from Olama, Anthropic, OpenAI, and really get a better sense of how it performs for your specific problem. And things like Langfuse really help us dive into that question and understand what's happening under the hood.
Yay, that means the questions I wrote might be perfect for you because I have a lot of questions about that. Okay, what about you? Tell us your name, what you do, and what you're passionate about.
Yeah, one of the founders of Langfuse, and Langfuse is mostly like observability for LM applications, which nowadays is mostly like agentive applications that do tons of things or that are more like conversational, and thereby you have like this kind of like multi-step problem of like planning and then following through. And generally it's about like observability, so understanding what's actually happening, then evaluating it offline and online, so both in development and in production, and then running like very structured experiments on it or managing prompts across like different sorts of teams where especially then domain experts or people who actually know something about the subject then come in. And I think, I mean, evaluation is one of the core issues, especially when like applications get more agentive or more complex. And I'm specifically excited about how to run evals well in like hundreds of millions of executions, because some of the teams that we work with, like Khan Academy, Samsara, they have like a lot of traction on their applications. And it's really then interesting to understand like what to take back into the development process when something is executed many times. And I mean, with Goose, it's very similar. Like, I mean, you directly see value when you use it, but then the question is, I would imagine then when working on Goose or in selecting model, it's really interesting to understand like what do I need to do to like raise the bar of how good this is.
Wow, wait, can I have more context? You say you work with Khan Academy and Code Academy. They have AI agents, or are you using those to help you understand how to interpret code?
These were just like some of the like teams that we work with as well, where like for example Khan
Oh,
Academy or Samsara or like many like Twilio, like many like big name brands that basically then run their LM agents while using Langfuse. So like my days are usually talking to teams and building product to help them move faster.
awesome. I didn't know they had any of those. Okay. So, I mean, like, I didn't know those companies were like diving into AI. I'm like out the loop. So tell us, what is Langfuse? But tell us, like, if I was 5 years old, like, explain it to me, like, if I was five.
Okay, I'll try.
I know,
So
hard,
if we have AI agents, which are basically interns that do things, then the question is, do these interns make useful things, or how can we direct them into like better ways? So I would say Langfuse is keeping track of what interns do, and then helping you understand whether it was useful. And if you have multiple interns, so multiple models, helping you understand which one performs better or where something goes off rails or is insecure, unsafe. So it basically directs you in the way how you direct the intern what to do.
I like that description. That was really good. Like you're like, which intern is performing well? Love that. All right. And then for you, Alice, I just have one question before we dive into the demo. Why did we as a company decide, or your team decide to integrate Langfuse into Goose? What debugging challenges were we seeing that Goose had prior? And we were like, yo, we need to get Langfuse right now.
Yeah, I think the main one is just like Goose sessions can be really long. So if we're talking about a session that has like 100,000, 200,000 tokens, we have log files, but you'll just see a massive log of JSON that has a bunch of information about messages sent, tool requests, responses, agent messages. So it's actually really hard as a human to just like visually parse all of that and understand what's going on. So we were looking for some kind of tool that would provide a nice interface for us to view kind of those logs in, that we'd be able to navigate and quickly understand like, oh, this is exactly where kind of Goose went wrong doing something. When I asked that specific question, what were the tools that it tried to call to answer that question? And so Langfuse, we were looking for something that was ideally open source, that we could run locally, have it hosted on our own machines. A lot of concerns around privacy, especially given the sort of data that we deal with. And so Langfuse just offered kind of the easiest setup for us to get going with, and we liked their interface, and it was really easy to integrate with them. Originally, we used their Python SDK when Goose was still written in Python. We migrated our code base over to Rust, and then ended up using the Langfuse API to batch ingest our traces, and that also worked really well for us too. So it's kind of generally has been like really easy to integrate and makes it easy for us to look at and understand our sessions if we want to do some like deep dives into what might have been going on with the agent.
Love that. I do usually have some really long sessions with Goose, and I do love that Langfuse is both open source and has the option to do cloud or local. So I think it was a great choice. All right, y'all. So I'm going to do something that's a little bit scary for me, everybody. And I need the audience to like, get involved. The first demo, so I'm going to do 2 demos. First demo is probably going to be mostly me and Alice and Marc just interacting. And then for the second demo, I need y'all to chime in. I feel like the chat's a little bit more quiet than it usually is. So talk it up, y'all. All right. So first off, what I'm going to do right here, now maybe, I don't know if I should zoom in a little bit, right? I have Goose open. And what I'm going to do is I'm going to put a prompt in and look at the trace in Langfuse. I don't know much about Langfuse, so I'm going to ask Marc and Alice questions off the top, or if they want to just chime in and be like, oh, that's this, if you didn't notice. And then for the second demo, I'm going to ask the audience for input of like what prompt you want to put in, or like fill in the blanks. So the prompt I'm going to do is one that I think is a fun one. Basically, I'm going to have Goose, and I don't know, it might fail since I'm sharing my screen. I'm going to have Goose basically do the following things. I'm going to have it play some classical music in Safari, dim my screen brightness by 2 levels. Let me put my screen brightness up a little bit so that there's a difference. Is it doing it? I didn't see it. I don't know if it's because I'm sharing my screen. And then I'm going to have it like do a little bit of research. If it fails, that's okay, because what I care about is seeing the traces in Langfuse. So I'm going to go ahead and press enter, or go ahead and put in the prompt. So it's working on it. And once it finishes, I'm going to go to the Langfuse, I don't know, console. Is that what you guys call it? And it'll work. Okay, so it did, my screen did go dim, but on
Attention New England homeowners. Imagine waking up and finally walking into your dream bathroom. Beautifully.
This was almost classical music.
Oh, not bad.
So it kind of did it, but just on my other monitor. So you guys didn't see that it actually did. It turned down the brightness, and then it started the music. It just turned off the music for me because that's part of my prompt. And then it did some research as well and put that research into a spreadsheet. So a little bit of a hiccup just because it didn't know what monitor to put it on, but it did work. And y'all heard the ad. I was like, oh no. All right, so let's go ahead and look at Langfuse. and see what happens here. So each thing I'm assuming is called a trace, right, Mark? Okay, and then when
That's correct.
okay, cool. And that's 12:59. Oh, I guess I have an existing trace from when I first did a call. So the first thing I happened, I don't understand, guys. Like it starts off with like, okay, it starts off with my user message. I'm going to say what I think happens, right? It starts off with my user message of me saying like, hello, are you working? And then for some reason it puts out this whole entire system prompt. And after that, I don't know, it does it again. And after that, it has me saying like, hey, here's what I need you to do. And it starts dispatching tool calls such as like, okay, it's like, I'm going to use the developer extension, but I'm going to use a text editor tool call. And it says that it's writing file to text, but I'm not really sure if I understand all of it. So any chance you guys can like tell me like what's happening behind the scenes, why it does certain things, and either one of you feel free to chime in.
Yeah, so if you kind of scroll up to the top and click on that reply, what's happening is Goose is running kind of like a while loop upon each user input. So when you ask a question like, hey, are you working? Then that gets sent to the LLM provider. So if you click complete, this is essentially everything that gets sent to your LLM provider. So that includes the system prompt. Right there, you can see the tool. So like there's some developer tools that kind of tells the agent what sorts of things it has access to, like bash commands, read file, write file. There's some, I think, examples of like things that the agent can do with the tools. And I think if you keep scrolling down, so I
have a prompt.
I think you probably have. I think you must have Goose hints. Yeah. It's also like loading your Goose hints, and so that gets like added to the system prompt. And then then right there, you'll see kind of above, if you scroll up a tiny little bit. So that's the user message. Hello, are you working? And then right underneath that is what Goose responds. And so what's kind of nice about this is that you can go in and see like, because in the Goose window, you don't see what the system prompt is. You don't see what Goose hints were loaded. But if you kind of want to debug and know like what exactly was the model looking at, what did we send it, you can see that full input and then see right there exactly what the model responded with some extra metadata around like how many tokens were used. Did it stop because it ran out of tokens, or it reached a stop token or something? And so this kind of just gives you a more comprehensive view. And then what happens after this is there's a loop. So if the agent decides it wants to call some tools, I think lower below you ask it to do a number of tasks, it'll queue up all of those tools. So you'll see that dispatch tool call if you kind of scroll down on the right side.
Oh, sorry, this right here. Oh, these are the 3 loops.
So that's the agent saying, I want to dispatch and call these tools like the text editor to write to that CSV file that you had. I want to use computer controller to open up the numbers application. And so it'll execute all those tool calls, send it back to the LLM provider to look at those responses and then figure out like, do I want to take more actions? Do I want to call more tools? Or am I done? And then I just tell the user like, what did I finish or what did I kind of accomplish there? And then that's when you're able to enter more input.
Awesome. Do you happen to know like what are the different stop reasons that it has? Because that was my first time paying it. Like I've looked at this, but I never noticed that area where it said stop reason. Maybe it was right. Oh, oof. It was in one of these, but I think it said stop reason, or it said reason and it said stop. And then what are the other reasons that it might?
I think you can also provide your models like a stop token. We don't do that in Goose, but certain LLMs you can provide like a XML tag or something that indicates you want it to stop generating. Or if you want to produce like valid JSON, for example, you might add like an curly end brace or something so that when the model generates that token, it stops producing more tokens. We don't actually use that in Goose. I think another reason could be if you have a low token limit on your model. So if like you're maybe using one of the OLLAMA models or kind of an open model that has only a context window of like 2,000 tokens, Goose, I think the system prompt is already like 1,000 tokens. So it might just run out of tokens for the output generation. And so it might stop for that reason.
Okay, that's good to know. And I think I was talking about this area where it says finish reason, and this one says tool calls, and yeah, but I don't know. You might know.
Yeah, not totally sure about that either. I guess the reason there might just be like it decided that it just wanted to generate the tool calls
Okay.
in that message rather than additional like text content.
Okay, cool.
And also, my other thing is like Goose is very much like model agnostic. So I would also assume that a lot of these kinds of like logs are very then like model dependent and not necessarily something that Goose actually picks up on.
Okay, that's good to know. And then Marc, I actually had a question. Any like reasoning on like how you like set up the UI or different things that you wanted people to get insight into, like what is the difference between a trace and an observation and stuff like that?
Yeah, maybe quick deep dive here is generally like when we started out, we built like code like generation agents as well, like going from GitHub issue to pull request, and just for us with the same issue that Alice described of like it works with logs on like standard out, or it works when reading from like a Postgres table. But one, it doesn't really scale if you have a lot of them, and it's really difficult to view. So in the end, you start building like your own abstractions to then like see all of this raw data, and then you want to like aggregate it through like millions of executions. It gets like becomes like a performance problem. So the core kind of primitive are traces and spans, very similar to like OpenTelemetry or something you might be used to in, for example, Datadog. So we just piggybacked on basically the abstractions that are already out there that are well defined, because they like then help to drive interoperability if teams like pipe the same traces also into their traditional observability stack, for example, for alerts on like model outages, for example. But then in Langfuse, usually like this nested structure of different things that happen within like an agent is really helpful, because usually you want to evaluate the whole execution as like a unit or integration test, but then also come down to, does my tool execution actually work when I do like a retrieval call, for example, on additional context? So it helps to structure the problem into the overarching problem and sub problems, because maybe the agent as Goose can fail on the sub problems when the overarching problem didn't work. Maybe here interesting could be to switch to the timeline, because with Goose, lots of things are on the right side. You see this switch.
I didn't see this before. Cool.
And thereby, if you hit like the plus at the top left, you should then see like timings. Probably you need to scroll to the right as well, because I think there's like a lot going on here. Just usually like more complex applications, interesting to see how these stack, like how many of them can be parallelized. I think with Goose, just a lot of the like time is probably like bound to the tools that are used as well next to the models. So that's why probably we'll see a couple of gaps here.
Wow, this is cool. Thank you for pointing this out, because when I initially like explored this area, I didn't notice the timeline section. And the point out or the note that you made about making this interoperable or using the same terms so that it's interoperable for people, that's really interesting. Because what I was thinking is, oh, they just used it because it would be familiar to people, but it's a little bit more beyond that. Okay, it's just like how are you guys ensuring that the AI behavior is like observable AI behavior doesn't expose security vulnerabilities? Because I was thinking like it's showing everything that's happening. Will it expose other things that are underneath the hood that we don't want exposed?
Yeah, I think generally with LLMs, kind of like security by obscurity doesn't really work in general, because like usually you could then like prompt engineer around in many use cases, meaning like exposing, for example, like a system prompt that should be kind of like hidden, which is not the case for Goose, but could be the case for other applications. I mean, generally this doesn't really apply, because there's like a lot of like prompt injection techniques going on that could exfiltrate these kinds of like prompts. So generally you need to assume that the user should be allowed to see the full trace, and there's nothing that should be hidden within a trace. But then, I mean, it's usually more about if you now run such an observability process in like an like application with actual users, it's more about like who sees this kind of information, but then any kind of like policies that you would have in a team to see production data or sensitive data would also apply to what you log to Langfuse. And many teams then use like some sort of data masking on the like integration side to mask out credit card data, emails, domain names, whatever could be like sensitive, to then not apply, I don't know, PCI compliance for credit card data that you don't need to be compliant in Langfuse for credit cards because you strip them out. But generally like storing the raw payloads to the models is really helpful, because otherwise, if you strip too much, then in the end, you can't debug anything and you can't replay problems.
Okay. So what I got from that is sometimes people mask some of like the PII, but we don't want to do it too much. Alice, do you know by any chance how we handle that, or that might not be on your side?
Right now for Goose development, we use this mostly as like a developer tool. So it's all running locally. All the data is on your like local machine. We're not sending it to any servers or storing it. I think we sort of had in mind like we want to cater to a lot of our open source users who are sensitive to these concerns about like they probably don't want us collecting all of their Goose sessions somewhere. But we have this ability for you individually to inspect your sessions locally. But that said, I think like for block internal use cases, we are talking about some way of maybe centralizing some of this data collection for this kind of debugging purpose, or later if we want to fine tune like any of our own models on kind of internal Goose usage, then kind of turning on Langfuse for everybody and sending it to a central place could make sense, but only for certain applications where we're confident they wouldn't have data security concerns, or we probably need to apply this type of like PII masking or other kind of data security measures to it.
Okay, so that makes sense. At the moment, since we're local, there's not like that masking put in place because it's not in the cloud. Okay, I have another question that I'm also wondering, maybe this is why the audience might be like, what's this all for? Like Langfuse is something that I think, or from my perspective, that this is helpful for someone that's developing Goose, or developing an AI agent, but maybe not really feeling that helpful or useful to someone who uses Goose. So is there any like use cases that I'm not thinking of that a user might want to use like Goose on their own? I know we came up with a tutorial too to enable people. So yeah.
I was muted. I think it's mostly like if you're really curious what's really going on within Goose, it's really cool because, I mean, Goose is doing so many things. If you prompt for many, many things, it's, I think, like understanding what's going on under the hood. Goose is open source. Goose reports traces in a standardized format. It's cool that you can get this from Goose, where many other tools would hide this. What's actually going on would hide this from users. So I think the transparency that you get when using Goose is cool, and then looking at them can be just interesting, even if you don't develop yourself. I mean, when you technically could thereby maybe benchmark how different kinds of models perform differently and look at the history again. But yeah, I think it's most interesting if you contribute to Goose, unless if you're like a user and are just like running like your instructions and have fun playing around with Goose.
Yeah. Okay. So it could be like just nerding out and just wanting to know. And I think that's, you know what, that is cool because like you said, AI is a lot of a black box. You're like, how did it do this? When did it come to this situation? I was actually hoping in my demo that something would fail. And then we would like, I'm like, okay, everything worked. Boo. This is my first time being sad that an AI demo worked. I wanted to see like something fail. And then we look through the traces and be like, oh, here's why it failed. I'm actually curious. Do you guys happen to know, you might not, do you happen to know what happens when, or like what Langfuse does when an LLM hallucinates? Does it like pick up on that by any chance or put any like message in there?
Yeah, usually like evaluation is really like the biggest problem that we tackle with Langfuse, where, I mean, comparing to traditional observability, where usually when like an API fails, you know it's not working, or you have like some kind of like error codes. Okay. Where now with LLMs or agents like Goose, the problem is it will continue to do many things for you, but maybe it's not the thing that you instructed it to do. So evaluation is usually the biggest problem, where usually a mix of, for example, like user feedback, of directly explicitly saying in the Goose UI whether something worked or not, can be interesting. But then usually the development teams of agents use Langfuse to put in evals server side within Langfuse, or to then run like evaluation batch jobs on the data that was collected via Langfuse. So you can, like with our API and SDKs, just fetch the data. So imagine you're just using Goose for like a week, store the data, and then you can fetch it again to evaluate, to understand, which kinds of use cases worked really well, which didn't, what did I learn from the data? So that's like something many of our users do when they build for themselves or when they build for other users. So I think that's what Alice mentioned with regards to block internal data collection to then improve Goose based on data. So these kinds of workflows usually happen, because it's not that clear cut whether something works or not, because like what's even a hallucination in this sense?
Yeah. Okay. This makes a lot of sense to me. Now that you said that, I'm connecting what Alice said. And I was literally sitting there like yesterday, like, I don't get how it would notice if there was a hallucination, but they compare the data afterwards, after over a certain period amount of time. I really love learning from y'all. Okay.
Yeah, like I'd say just to add on that, like one thing that I'm looking at a lot these days is local models with Goose. So things that are really small, not necessarily as powerful as what you can get from OpenAI or Anthropic, but obviously cheaper since you can just run them on your machine. So I've been playing around a lot with like DeepSeek 70B and smaller, the Qwen 2.5 models, 5.4, and a lot of these models suffer with tool calling specifically. So like one thing I was trying the other day was to get Qwen 2.5 to write like a Flappy Bird game in Python using Pygame. And a lot of the open models just wrote the code for me directly as like a response, but none of them invoked the developer tool call to actually create the file. And so if you're trying to kind of get a survey of, I want to know how do all of these open models stack up against like these closed model providers, I'd like to just run them all at once, collect the kind of observations on did they call any tools at all, and find like, oh, like none of them actually called the tool. And so it really, I think, is helpful for this sort of post hoc analysis where maybe you want to kind of run your agent independently and then come back later and see what did it actually do. Did it call the wrong tools? Did it try and call any tools? So I think that's another area where it can be really helpful. And then one other thing would be a lot of people in our kind of GitHub issues on our public repo often will bring problems with Goose to us where they'll say like, I tried this and it didn't work. And a common sort of triaging workflow is asking them like, share your session file with us so that we can go and see like, what were you doing when something broke. And so I think if there were an easier way for people to like look at their sessions and see like, oh, it's because I passed in try to pass in my whole code base and it doesn't fit into context, and then like Goose crapped out, we'd say, oh, it's like because you tried to pass in something that was too big, or oh, like you wanted to access the web but you didn't have the fetch web extension turned on or something. So I think what we're doing right now is people will share these manually with us, but maybe if they use something like Langfuse, they'd be able to sort of do a little investigation first themselves and kind of pinpoint where they were having their own issues.
Sounds like my team needs to empower some of the users to go ahead and use Langfuse more often. I didn't realize that you all behind the scenes went and looked at the logs of somebody else's session and helped them out. This is actually really interesting. Okay, Marc, I have a question on like what inspired you to build Langfuse. Now, I have two theories. Don't get offended. One theory is either you really, really, really love observability and you were like, I just want to build an observability company. Or the other theory is like AI is booming. What are they not doing in AI? And you're like, observability. Is that, did either?
Can I pick a third option?
Yeah, what's the third option?
I put it nicely. Like together with my co-founders, I tried to build Goose 2 years ago. It didn't work because it was kind of like limited by generally like we wanted to go from like GitHub issue to pull request. So if you write like a spec to get to something that's like a nice PR that does like multi-file edits, and just like multi-file edits was something like GPT-3 was, or this kind of like capability of model was really, really difficult. It involved like a lot of like logging to Postgres, a lot of like just looking at logs in a terminal. We just realized like this is really hard to get from like a demo that's really cool to something that reliably works. And at the same time, we did like Y Combinator, and like around us, there were like hundreds of teams who worked on like LM applications. We just realized, okay, this is still early. Like everyone is really struggling to go from demo to something that's like reliable. And if everyone around us who are like exceptionally good at what they do, if they all struggle, then like the world will wake up to this and realize, okay, there's like so much like latent potential of building applications, but it's really difficult to build something useful. So we realized like our tooling is probably more interesting short term than like our kind of like Goose competitor alternative, because we would need to wait for another 1 or 2 years until like model capabilities are good enough to actually build meaningful diffs, because our diffs that we generated, like single file, simple edits, where in the end you don't create that much value. If it was like multi-file, it just never worked. So yeah, that motivated us to basically help teams accelerate their efforts. Launched this in like 23. open source, and then took off from like a product hunt and Hacker News launch. Like worked really well from the get-go.
Wow. Well, I think it was a good pivot. But and maybe I'm just out the loop, but 2 years ago, I didn't see as many powerful agents. I just seen them doing like single file edits too. And I was like, okay, I guess this is cool. And then I remember the point that Alice made about like the open source models. This makes so much more sense because I would like be playing around with Quen and I'd be like, it's not doing anything, it's just returning output to me. Oh wait, so what other like gaps do you all see in the like AI tooling space right now? Like either Alice or Marc, both of you, either one, I would love to know, like, what do you all think that is a little bit weak right now that as an industry we need to like build up upon?
I can talk about our roadmap because that's basically my thinking, but Alice, do you want to go first? Okay. Generally, like there's, I think, like two ways in which way like engineers build like very complex applications such as Goose. One is by being very methodical about like tools and different states and different prompts that are used across these systems, where then often the question is, are these different states invoked correctly? Like, how do these agent systems actually work when they're executed? And the other philosophy is more around like that basically model capabilities increase a lot, meaning just like a single prompt, good tools in a loop work well enough, and we can just rely on these things becoming better. But both basically have a kind of like data visualization analysis problem when the agents do many things. And I feel like, at least for us internally, something like deep research by OpenAI really created like one of these first agents where it just goes on for like 20 minutes and does things that are like economically viable and useful. And if we now take this and put this into other use case domains, as for example, what Goose is doing, or let's assume we like augment other workflows where just like AI is doing things for like 20 minutes straight, and then comes back, where currently it's usually for minutes and not like 20 minutes, then just like the data visualization analysis problem is just growing a lot of how to even understand what's going on. So we are mostly focusing on like visualization and evals for these kinds of more complex and longer executions, and then how to make like human review of feedback scalable to these like very many steps of an agent execution. So this would be like one execution. Then the problem is if you have like 100 million of these, how to aggregate basically like results or insights from like 100 of millions of executions. So these are like the main things that we're working on right now.
That's cool, exciting. What about you, Alice? What's your thoughts on like AI tooling that can be improved, especially from a machine learning perspective?
Yeah, I think somewhat similarly. Like, I think evals are really the thing that are really, really hard to do. Like right now for coding agents, I think the state of the art is like SweBench, but it's really hard to run SweBench, honestly. I just saw some blog posts the other day, I think by Anthropic, that was about how their team has like Claude play a game, play Pokemon, I think, and they like stream it on Twitch or something, so you can kind of see like their newest model releases playing a game, because they're like, yeah, we use all the traditional benchmarks and evals that other people use, but sometimes it's hard to just get a feel of like, is it getting smarter? And putting it into like a game environment can kind of give you some sense of that. And so similarly, like working with a Tetris game, kind of trying to see like, for these more open-ended kind of exploration kind of problems that I think are representative of general intelligence, how do you actually eval that? You can do things like, I don't know, check, like, did it make a right tool call? Did it make this tool call? But where there's like a really big search space of possible sequences of correct tool calls to get to one of many correct outcomes, it's really hard to design like your eval system to actually identify like which sequence got you to the correct answer. And then when you think about doing this at scale, that's also like very challenging because the models all have like their own quirks about preferring to use like find and replace versus like a full file rewrite or something. And so for Goose, like we really want it to be, I think, model agnostic ideally, and like we really want to support the open source ecosystem. So I think something important to us is to be able to do evals on like Claude versus O3 versus DeepSeek versus like all the open models coming out at once, and really get a sense of where they are in performance. And that's just very hard right now. I think designing like the right task to eval, measuring like once it runs through those tasks, whether or not it succeeded, and then kind of doing a deeper investigation into like where it might have gone wrong or off the rails at different points. I think all of this is very tough to do.
Wow. Okay. Sounds like I need to start an eval company if I had enough big brain energy. But I didn't realize that's why they made the Pokemon game. I thought it was just to be like, you know, I don't know, more popular in social media or something like that to like create some buzz. But it's just for us to, or just for them to be able to evaluate like how the agents are is working. Yes, Mark. What's up?
Yeah, I think like just creating meaningful evals for these kind of like long running problems. I think Alice put it nicely in like very open ended, and there's not like a clear expectation for what a good next turn is. It's really difficult, and I like the Pokemon idea.
Yeah, I want us to do when's our game coming out, Alice? All right, so before I ask you guys the last question, I normally play a quiz for the audience. I hope I didn't lose you all with my demo that was a little bit wonky, but go ahead and participate in the quiz, and then I'll come back and ask like one last question, which will just be what's on the roadmap. I know you guys said evals. Anything else for both Goose and for Langfuse that we can look forward to, and then we'll go ahead and wrap up. All right, see y'all. All right, cool. Good job on the quiz, y'all. So back to Alice and Mark. What's on the roadmap? What's something exciting? I know evals. That seems like the big thing for y'all. But what other things can we look forward to in Langfuse and Goose?
I mean, I mentioned like the agent focused roadmap.
Yeah,
Next to it, we have like a big roadmap focused more on like collaborative prompt management, where then usually, I mean, in Goose, a lot of the kind of prompt is user defined, where you bring in the task and instructions, and then the Goose hints. But in like other agent applications, like you have a lot of like domain experts working on how to improve the prompts and the system prompt. And we will build a lot of tooling around how this works and how to then evaluate whether these changes that you make to your agent actually work. So there's like a big one. And regarding to like agents, we want to focus more on then also the like session level. So if you have like an ongoing conversation, how to evaluate this nicely, because currently a lot of the evaluation is like a single turn based, like single run. Like you give an instruction, what does Goose do until it completes, and it's not like the whole conversation of you going back and forth with Goose, where often there's some kind of like insights from the conversation of you being frustrated, or you being like going step by step in single chunks, or you trying to do the whole thing at once. So there's stuff to learn from looking at the whole conversation. So we want to go deeper on this as well.
That could be cool to see the insights. What about you, Alice? What's on the roadmap that we could reveal?
I think there are definitely a lot of exciting things. One is something we're calling Goose Bench that the team is working on, which is like providing benchmarks for Goose, kind of a lightweight set of evals. And then there's also some stuff around like trust. I think some users have wanted sort of more controls over approving Goose commands before Goose executes them. So kind of this trust progression idea. There's some UI improvements. We're also taking a look at adding reasoners to enable like a planning reasoning mode in addition to an operate act mode. So yeah, I think there are a lot of kind of exciting things across the spectrum upcoming on the Goose roadmap.
Awesome. I'm excited to see both. Excited for the Goose Bench and everything that comes with that. Y'all, okay, do you have any last words you want to say before you leave? I guess I should say people should go ahead and check out langfuse.com, which I'll put up on the screen right here. And then also, if this is your first time hearing of Goose, or you tried it out maybe once, go back and try it out again. Our repository is at github.com/blog/Goose. You can feel free to contribute or try out the tool and plug in any LLM you have. Yeah, Alice and Mark, any last things you want to say?
Yeah, I'd encourage people who love Goose to goose around with Langfuse with Goose by just following, like, there's like a quick start guide of how to set this up locally on your machine. So you just want to see what's happening while you instruct Goose. I think this is cool, and there's like a quick tutorial on the website of how to actually do this.
Yeah, it was really good because I was able to follow it and show y'all. So thank you so much. Someone said, will we show something? I showed something in the beginning. You can go ahead and rewatch it when the stream ends. All right, y'all, bye. Have a great day.
Thank you.
Fetch and process content from the web? Here's how to plug and play. Enable the built-in fetch extension. Now let's play. Hey Goose, create a web page that fetches programmer jokes from the official joke API, display the joke, and let users guess the punchline. Show if they're right or wrong. In less than a minute, Goose fetched a joke from the API, processed the response, and built an app that uses this data. Thanks, Goose! What's the object-oriented way to become wealthy? Is it inheritance? You're such a silly goose. To get started with Goose, visit block.github.io/goose.